What's up, guys? You have now made it to scientific notation with negative powers of 10. This at the top of your worksheet should say Notes 3. So let's take a look at what it says. It says you can use what you know about writing very large numbers in scientific notation to write very small numbers in scientific notation. Notice how the decimal point moves in the table below, and then we're going to complete the table. So when it's 2.345 times 10 to the 0, that would just be 2.345 in standard notation. If we were to say 2.345 times 10 to the 1, so I'm looking at the one right below it, then that means that we've taken that decimal point and we've moved it over one spot. So it was here in the first one and we've moved it over one spot, so now it is here for the second one. And then if we take that same number, 2.345, and move it times 10 to the second, we're taking it and moving it twice. So it's no longer here. It is moved over to where it is here. So knowing that, now let's try to complete this part of the table. So 2.345 times 10 to the third. We will take that decimal point and we will move it 3 times because it's 10 to the third, and your final answer on that one in standard notation would be 2,345. And if you want to put a little comma there saying 2,345, you can. This is the way we usually write numbers, and that's why it's called standard notation. Anytime you're looking at scientific notation, it wants a times 10 to the something number, and it wants, remember, that first number to be somewhere between 1 and 10. So if it's asking write it in scientific notation, it's going to be a number between 1 and 10 times 10 to the something power. If it wants it in standard notation, that's how we usually deal with numbers. It looks more standard, if that makes sense. Okay, let's look at the second two columns. We have 2.345 times 10 to the 0, so that would just be exactly how it looks, 2.345. 2.345 times 10 to the, this time, negative 1. All right, negatives are new. So what they did when it's a negative 1 is they took our decimal, and this time they moved it the other direction. I don't know why my pen is doing that. They moved it to the left because it's a negative, so we're actually taking our standard number and making it smaller. So that's why the answer looks like 0.2345. If it's to the negative 2, you're taking that same decimal and you're moving it 2 places to make our number even tinier, which is 0.02345. So now, knowing that, let's take it and move it times 10 to the negative third. So we'll take our decimal and make it even smaller by moving it 3 places to the left. So it would be 0.00235. So this is our standard notation, and again, anything in scientific notation is going to be between 1 and 10 and times 10 to the some power. Okay, let's look at the next example. It says a typical human hair has a diameter of 0.000025 meters. Write this number in scientific notation. So again, scientific notation means we're going to have a something times 10 to the exponent. And remember, our first number is going to be something between 1 and 10. So we're going to take our decimal, we're going to move it to the right until we can land the decimal, making our number somewhere between 1 and 10. So that is going to be 2.5. And since we're moving the decimal since we're changing our number to scientific notation, we want a times 10 to the, and let's look at our number itself. We're representing a tiny number, super tiny. It has a decimal with lots of zeros before we even get to our number that's between 1 and 10. So it is going to end up being a negative exponent. If it helps, look at our chart again. Negative exponents, teeny tiny numbers. Whole number exponents, bigger numbers, like in the thousands. So these are just two different ways to represent the same number, and so are these. It's just that, again, negative exponents, tiny numbers. Positive exponents, big numbers. So since this is a tiny, tiny number, it is going to be a negative exponent, and we moved it 1, 2, 3, 4, 5 times. So it is going to be negative 5. 2.5 times 10 to the negative fifth. Okay, part B says divide 0.000025 by our answer that we got in part A. If we were to do this, let me help you out. We'll use a calculator or whatever. If we were to do this, we would get 0.00001. Okay. Okay, lastly on part C, it's saying combine your answers to part A and part B to represent this in, therefore, total scientific notation. I actually accidentally did that earlier. I combined it already. I think in the first part it wanted us to just put 2.5, and in the second part it was how many times we moved it, and now it wants us to write the total of what we did altogether. So for this part, sorry, go ahead and write the total answer that we already got, which was 2.5 times 10 to the negative fifth. That should be smaller. That should be here. Let me try to fix it. Negative fifth. There you go. Okay. Second part. To write a number less than 1 in scientific notation, move the decimal point to the right and use a negative exponent. I don't want you guys to get too hung up on which direction you move it. All I want you guys to know is if it's a tiny number, we are representing a tiny number by making it bigger. We're putting the front number between 1 and 10, and we're representing that it's super tiny by showing you that the exponent is negative. And again, if it's a really big number, then the exponent will end up being positive. So don't get too hung up on do I go left, do I go right. Just make sure you know that if it's a tiny number, it's going to be negative. If it's a big number, it's going to be positive, and you still move the decimal as many times as it takes to get your number between 1 and 10. Alright, and then the last thing it says on this page is writing in standard notation. Standard notation is going from the scientific version notation, so 2.33 times 10 to the negative sixth, and making it more like a number that we would probably use in everyday writing, which is 0.0000233. That's how you would normally, I guess, see a number, which is why it's called standard notation. And again, moving it from scientific notation, this says you would move it 6 places to the left. Again, don't get hung up on which way do I move it. Just if it looks like this and you're changing it and it's tiny, you're going to move the decimal back that many times. Okay. This is a good time to pause the video and try the 4 problems that we have for you in the Your Turn section, and then push play again to see if you're right. Alright, the first 2 say to make it scientific in scientific notation. So that means our answer is going to have a times 10 to the, and our front number is going to be between 1 and 10. So I'm going to move it around all 4 of these zeros and then one more time to make our number 8.29. And how many times did we move it? We moved 4 zeros and an 8, which is 5 total times. And so I'm going to make it -5 because we are representing a tiny number with lots of zeros after the decimal. On number 2, it looks like I will move the decimal all the way over to here, and that will make my number 3.02. You have to include a 0 if it's between 2 significant digits, and significant digits are numbers that are not 0. The 0 in between becomes significant because it's between 2 other numbers, but all of these front zeros we do not need to include, and if there were any behind, we don't need to include those either. Those are not considered significant digits. So 3.02 times 10 to the negative, because it's a very tiny number. Let's see how many times we move that decimal. Looks like 1, 2, 3, 4, 5, 6, 7, 8. So -8. 3.02 times 10 to the -8. Alright, on 3 and 4, it gave it to us in scientific notation, and they want you to work backwards this time and make it standard. So this time we're going to make it look a little bit more like maybe you and I would normally see it, since we're not scientists. All right, so 10 to the negative 6th means we're going to take our number and make it even tinier by moving the decimal 6 places. So grab that decimal and move it back around the 1, and then that would be 5 more zeros. So 0.5 zeros, that's a decimal. 1, 2, 3, 4, 5, and then you've got your 1, 0, 4, 5. You have to put all significant digits on there, so that would be all the way to the 5. All right, and then on number 4, 10 to the negative 5th means we're going to take this number and make it even tinier by moving the decimal 5 places. So we're going to go around the 9 and then around 4 more invisible zeros that we're going to make visible. So 0.1, 2, 3, 4, and then you've got your 9, 9. All right, I've seen kids make the mistake where they keep the decimal point in both places, like they would have it here too still, and you need to be sure you don't do that. Once you move it, it's moved. It's done.